I live in Wisconsin.
I know. Ask questions.
What's the question?
I know, right? Good grief. Okay, silliness is over. The sooner we get through this, the sooner you can get back to doing what you need to be doing. We are going to talk about something new today, and I hear some people are already sad about it, and you really ought not to be. If you can handle the 45, 45, 90, 30, 60, 90 stuff, then you can definitely handle this with ease. I feel like it's easier. One thing you're going to need, and I see Cassie going for it, is a calculator. You're going to need a calculator today. It's absolutely necessary. Go ahead and get one if you don't have one already. Get a calculator. Get a calculator. Okay, now I'm going to start hating on some people, and I'm not trying to call them out for just to be mean, but to call them out for a reason, and I'm not even going to call my name. I'm just going to tell you about some of the silly tests that I've graded this weekend. Okay, one silly test that I graded this weekend, on the front side of the test, they tried to use special right triangles. Every single problem they tried to use a special right triangle. This past test was supposed to be part Pythagorean theorem. Why didn't they use the Pythagorean theorem? I don't know. So one thing I want to talk about with this bell ringer today is how do we know when to use special rights and when to use the Pythagorean theorem? So why should I know that this is a special right problem? Ma'am. Oh, it tells you 60. And then I filled in the 30. Okay, if I were to pull out your test, the front side of the test, none of the angles were filled in except for the 90. So she's got a good point. How do you know it's a 30, 60, 90? You don't. Okay. That's one obvious reason. I need another reason. Why should I have known that this is a special right? Yes, ma'am. Yes, sir.
Because there's only one side.
That's the most obvious and best reason yet. If it's a Pythagorean theorem problem, they're going to give you two sides. Two of them. Every single time. They're going to give you two, you solve for the third. Since we were only given one, that's why I know it's a special right. And then you raised your hand, you had another thought.
It has the square root of 3.
The square root of 3 tends to go with 30, 60, 90s, like the square root of 2 tends to go with 45, 45, 90s. Okay, why am I taking the time to go over that?
Because we're going to need it.
Why are we going to need that? Where am I getting these bell ringers?
From the ACT.
Yeah, these are standardized test questions. So all I've done is take a standardized test question dealing with special rights and get rid of the answer choices. So on the ACT, you would actually have answer choices. Okay, so what part of the triangle did they give me?
No.
Yeah, they gave me the long leg, and I need to know the hypotenuse, and I need to know the short leg. How do I go from the long leg to the short leg? Ma'am.
Divide by the square root of 3.
Okay, divide by the square root of 3. I had a couple people on the test just divide by 3. So their answer would have been 2 square roots of 3. She is correct. You divide, you get 6, and then what does that make the hypotenuse? Ma'am. Somebody. Why is it 12?
Because you times the short leg by 2.
You take your short leg, you double it, and you get the hypotenuse. I know you can do this. I know you can do this. We've spent so long practicing this. I just need you to be able to recognize when to do this and when to use Pythagorean theorem, which is why on the test I didn't say specifically, like, hey, Savannah, on 5 through 10, use Pythagorean theorem, because I was wanting Savannah to realize, like, this is when I use what. I got to figure this out on my own. Okay, as for the next one, what do you think is the first thing we need to do to solve this problem? Let's move something first.
The 7.
I'm not going to move the 7.
The 6.
Let's move the 6 over. So I'm going to have square root of 5 minus 4x equals 13. How do I get rid of that square root?
Put it to square.
Okay, so let's square both sides. I like it. So I have 5 minus 4x equals, what is 13 squared? That is correct. Thank you, Asher. So it's 5 minus 4x equals 169. Then what do I need to do? Subtract 5. And I get negative 4x equals 164. So x equals something.
You divide the 164 by...
It would be negative 41.
It is a negative. It's negative 41, so my answer is G. G. My answer is G. 41. I know that's hard to read. Okay. Whole point of this being, and the reason I'm glad this one's here today, I have at least one person in the room, and this kind of reminds me in some ways of the Pythagorean theorem, in that you do 13 squared and you get 169. I had at least one person in the room who on the test, they got C squared equals 25. So they said the answer was C equals 25. Well, that's not true. You have to take the square root. It's actually C equals 5. So they're missing out 2 points per at least 5 questions. So they already were down 10 points, all because they didn't take the square root each time. It's very silly. Okay. Very silly. You okay, baby? Okay. As for your new notes, we're on to something greener, brighter, more beautiful.
Really, Miss
Yeah.
Compton?
Yeah. Okay, and this is a short week, so there's no way we're going to be able to have a test on this week, but a test is going to come. When we do finally take a giant Chapter 8 test, you better bet your bottom dollar I'm going to put special rights, and I'm going to put the Pythagorean theorem on it as well. Those are never going to go away. Never going to go away. Those are never going to go away. Okay, I'm going to do part of these today, and we're going to save part of these till tomorrow, because I want to let you take the Bell-Ringer test everyone else got to take, just so that you can have, no, actually, you're going to end up being the one class with no homework if we plan it out right. Okay, so what I'm going to say is that on the test, some people did not follow directions. So, for instance, the first 3 problems said, tell me if it's acute, right, or obtuse. I had one person write yes, no, yes. I thought we had made fun of that. We weren't going to do that. So we've got to make sure today we follow directions. If I leave my answer as a fraction today, have I followed directions? No, it says to the nearest hundredth. How many decimal places is that?
3.
Is it? 10 hundredths, so it's 2. Okay, if you're not sure, I'd rather you give me too many than too few, honestly. I'd rather you go too far than too little. So today we're going to talk about some trig stuff. I'm going to work one example, and we'll save some examples for tomorrow, and like Caitlin asked, hopefully no homework tonight. Let's back up. So you're in geometry. The class after me, hopefully for you, is Algebra 2 with trig, or maybe Algebraic connections, depends on how we talk about it. Algebra 2, or Algebra 2 with trig, or pre-cal, or whatever higher math class you take, is going to need trig. And we're doing the trig part today. This is where it all begins. This is the important part. So, remind me, because there is one person in the room who cannot label the triangle to save their lives. Hopefully we can get that fixed this week. The 37 is what part of the triangle? It's the hypotenuse. It's not going to change. I'm just going to put H for hypotenuse. It's not changing. Okay. So, this week we're going to talk about 3 new vocab terms. One vocab term is the word sine. S-I-N-E. Let me zoom in. One vocab term is the word sine. Another vocab word is the word cosine. And the last vocab word is the word tangent. Now, in real life, these are trig functions. And you actually see them all the time. In fact, you hear them. Sound waves are a trig function. So anyway, they're very useful in real life, but we're not going to get to that part of trig. We're going to stay in the geometry world of trig, which means we're going to stay in the right triangle trig. You know we love us some triangles. So all we're going to do is these words are going to tell us what to do with the triangle, which sides we want on the triangle. Okay, so do you know what an acronym is?
Yeah, like fanboy.
Okay, what's an acronym you needed in math class? PEMDAS. PEMDAS. Please excuse my dear Aunt Sally. Okay, there's a new acronym you're going to need for this. Do you remember what it is? Yes, I always say SOHCAHTOA. Some people say SOHCAHTOA. I'm not really sure. I always say SOHCAHTOA. So it's SOHCAHTOA.
Yeah, I'm not going to remember that.
Yeah, you are. Yeah, you are. Trust me.
You know my memorization skills.
Well, you're totally going to have it. Trust me. Okay, it's SOHCAHTOA. And we're going to talk about it in just a second. Obviously, if you want to write this in, the S is for sine. the C is for cosine, and the T is for tangent. But maybe you don't want to write that in tiny because that kind of is understood. The S is for sine, the C is for cosine, the T is for tangent, and the other letters are going to tell us what to do with sine, cosine, and tangent. So we're talking today about sine, cosine, and tangent. I know that sine abbreviated looks like sin, but I'm going to correct you all day long. It's sine. Sine, cosine, and tangent. I know. So one way to remember this acronym, I'm going to post a funny video later today because there is a funny one, and I'm not a funny girl. I just know SOHCAHTOA. But one acronym, similar to Please Excuse My Dear Aunt Sally, is some old hippie caught another hippie tripping on apples.
Acid.
Apples is what I'm going to say because I'm not going to say that out loud. You know what it is. You know what it is. Okay. But that's not how I just know SOHCAHTOA.
Yeah, man, you want some mean apples? Yeah, man, I'm
So why? I mean, come on. Focusing again. The H is the thing you already know. What is H in a triangle? So that's still going to be the hypotenuse. So all we need to know today, really, what we're fundamentally learning is what is the O and what is the A. So normally, no, I know, right? Normally we have legs. When we were doing 45, 45, 90s, we had two legs that matched. And then there was a time where we had, with 30, 60, 90, short leg and long leg. Today, they're not going to be called legs. They're either going to be called the opposite side or the adjacent side. And we're going to decide it using an angle. So, for instance, number one tells us that they're wanting to know the sine from angle L. So I'm going to go over to L. No matter what, that 37 is the hypotenuse. No matter what. But I've got to decide which one's the opposite of L. Is the 12 or the 35 opposite of L?
12.
Opposite of L.
12.
Yes, because it's on the opposite side. So we're going to call that the opposite. And we're going to call this the adjacent. So if you're looking at SOHCAHTOA, sine.
See it now.
Yeah. Oh, wow. Let me tell you. So goofy. So little time. Okay, so are there any questions about how I figured out that was opposite and adjacent? So I'm literally going to plug in numbers. So sine is always opposite over hypotenuse. That's what the OH is for.
What?
Opposite over hypotenuse.
Yeah.
Oh, you can't see what I'm writing. That makes sense. Okay, sine is always opposite over hypotenuse. That's the SOH. The CAH tells you cosine is the ratio adjacent over hypotenuse.
This is way too much drama.
I know, can't I tell you? It's really not. You just like to interrupt today because you want to postpone that test, but it's still going to happen. Tangent is opposite over adjacent. Again, SOHCAHTOA tells you everything you need to know. Sine is opposite over hypotenuse. Adjacent over hypotenuse. Tangent is opposite over adjacent. It tells you in SOHCAHTOA. So when I get my paper, I put SOHCAHTOA at the top, and I always get it right. So what I'm looking for today is we're going to do the fraction, and then we're going to type it in and get the decimal. So if we look at our first problem, they asked for sine of L, so we need the opposite over the hypotenuse. Well, if I look at my triangle, obviously the hypotenuse is 37, so for sure 37 goes in the denominator. And then we decided the opposite of L was the 12, so it's 12 over 37. Well, I'm not following directions because it said to do it as a decimal, so I need to type that in my calculator. I need the answer to 2 decimal places.
0.32.
Perfect. Okay, so, well, hand me your calculator. Did you do it already? Okay, Will typed it in. He got 324. Again, 324 doesn't round up. If we had 325, we would round up. We are going to run into that issue today. Okay, and then we go to cosine. Cosine is adjacent over hypotenuse. Now, do I always spell it out like this? No, I'm doing it to prove a point to you. Do I normally just plug it in? Yes, I do. But if I was taking a test, it doesn't hurt. Okay, so adjacent is 35. Hypotenuse is 37, so 35 over 37. When I type that in my calculator, I get some decimal. Okay, 0.945. So then we're going to say 0.95. We're going to round up.
Okay, so how can you tell which is the opposite or adjacent?
Which angle they asked me from. So since they asked me about L, the opposite of L was 12. The side opposite the L.
Okay.
That's how I know who's the opposite.
So 4, 5, and 6 from here.
Oh, don't know. Still my joy, but yeah.
Oh, I'm sorry.
Okay. Number 3 says tangent. Tangent's opposite over adjacent. Obviously, opposite is 12. Adjacent is 35, so I have 12 over 35. When I type that in my calculator, I get something.
0.34.
0.34? Okay. Are there any questions on 1, 2, and 3?
Wait, so they're always going to ask you for all of them of the same letter?
They did in this example, and they do on the homework on the back. Do they mix it up in life and sometimes only ask you like only sine of L and then just cosine of N? Of course, they can make your problems. Natalie's on to something. She's already caught on as to what's going to happen next because life goes wrong. So I'm going to steal that green. 1, 2, and 3, we were all dealing with the reference angle of L. On number 4, it changes. What's our new angle? N. Okay, so what is opposite of N?
35.
So this is the opposite side now. The hypotenuse stays the same. Lord knows that can't change. But this is the adjacent. So our fractions are going to change. So our answers are not going to be the same as they were before. They are not going to be the exact same. They're going to be very similar though. Okay. So with sine, again, we know sine is opposite over hypotenuse. Well, my hypotenuse is still 37, but the opposite isn't 12 anymore. It's 35. But hey, I don't have to bother to type that in my calculator because I already did it before. It's the same thing here. So I already know it's 0.95. And yes, that's always going to happen. That's always going to happen, ironically enough. Okay, and then cosine. I know the cosine is the adjacent over the hypotenuse. Well, the adjacent would be 12 over 37, because adjacent to n is 12. So 12 over 37 is 0.32. Hey, I already typed that in my calculator too. It was 0.32.
Imagine.
And the reason that's happening is because what was the opposite is now the adjacent. So there is a reason. I know you're thinking, oh my goodness, Miss Compton, since we keep using the same numbers, maybe number 6 is also 0.34, and you'll be disappointed.
No.
35.
Exactly. So we'll do opposite over adjacent, but the opposite is 35. The adjacent is 12. It ends up being the flip fraction of what we had before, the reciprocal.
2.91.
2.92?
Yeah. He rounded up.
Perfect. Again, they look really similar. They could be easy to get confused. Okay, I want to do the next ones in just a minute. I actually am going to be rebellious. We're going to come back through 7 through 12. I want to go to number 13 right now, and let's talk about it really fast. I know. So what we're going to do lately, or the next couple days at least, is we're going to figure out the sine, cosine, and trig values by doing this right triangle trick. But we're also going to literally plug stuff in our calculator. So 13, 14, and 15 are what I'm going to call a plug and chug, where you literally are typing straight in a calculator. But there's an issue with that. If you haven't noticed before, your calculator has a sine, cosine, and a tangent button. If your calculator does not have sine, cosine, and tangent buttons, you need to borrow one of mine. First rule. It needs to have those buttons. If yours does have these buttons, and after I show you how to type it in, yours is not as easy as mine, you have what I'm going to call a backwards calculator, and you need to see me to get some lessons on backwards calculators. Yes, it's like someone who has an iPhone trying to use an Android. It just makes life a little complicated. I can help you, but it's easier if you have a straightforward one. If you got one of my yellow calculators, someone have a yellow one? Also Mia. If you have a fancy one like Mia does, or like one of my yellow ones that Abby has, doesn't matter. There's still a sine, cosine, and tangent button. See? Sine, cosine, tangent. She still has those buttons. Doesn't matter. You're still going to have those buttons. Okay, so it's supposed to be the easiest problem yet. Literally all Caitlin's supposed to have to do is press, since it says sine 30, she's supposed to press sine and then 30 and then enter. And that's it. That's it. But there's a catch, as there is with everything in life. If her calculator's in the wrong mode, it's going to give her the wrong decimal, and then she's going to miss all the easy answers. So, words to the rise. You see how my calculator, or actually, Kathy's, do you see how it says DEG on the screen? That's what we want. We want it to be in degrees. Now, if you're using your own personal calculator, let's say it's yours, you use it every day, you're the only one who uses it. Once Will sets it, he's good to go. I know Victoria's using hers, so she'll be good to go. But if you're borrowing one of mine, I have so many other class periods, and they probably enjoy changing the settings. So there's possible that it's not going to be in degrees. So you either want to alert me, or I'll show you really fast how to do that.
DRG.
If you press DRG, you get options, degrees, radians, and gradients. We're only going to live in degree world, so you want to make sure degree is underlined.
Oh my god. I have to go from scientific notation.
You got to make sure degrees is underlined. If you have a fancy calculator like Mia, if you press mode, right now hers is in the wrong setting. Let me see if I can zoom in. See, hers is, ooh.
That's so many settings.
Hers is highlighted on radians right now. We don't want that. We want it on degrees.
Mine's got like 2
Yeah,
settings.
what's that called?
So I've changed hers. Now,
About 2 feet. Nice.
Now, Mia's net is set in the right setting, so she should be good to go. Again, I'm just going to press sine 30, and I get the answer, and it is 0.5. I realize I'm almost out of time, so we're going to stop what we're doing, put it up. Yes, take the calculator. Stop that for me.